Okay, let's do some examples of drawing Lewis structures for covalent compounds. I've listed the rules up here and steps for drawing them, basically condensed it into 5 steps. And the first one that you have to do is count the total valence electrons in the compound. All right, so the first example that we're going to start off with is a compound PCl3, or phosphorus trichloride. And so to count the total valence electrons, you'll probably want to know a diagram like this, which tells me some of the group numbers on the periodic table and their corresponding number of valence electrons. All right? So phosphorus is in group 15 right here, so it's going to have 5 valence electrons. And then chlorine is going to be right here in group 17, so it has 7 valence electrons. But in my compound I have 3 of those chlorines. So to count the valence electrons, I'm going to have 5 from the phosphorus plus 7 from the chlorines times 3. So that's going to give me a total of 26 valence electrons. All right, so that is step number 1. Then step number 2, I want to connect all the atoms to the central atom with a single line. So I'm going to put my phosphorus in the middle, and I'm going to connect all 3 chlorines to it. I'm going to spread out those chlorines a little bit from each other. And then it says, step number 3, for each line that I just drew, and I just drew 3 lines, right? Those lines represent covalent bonds, or sharing of electron pairs. So for each line, I'm going to subtract 2 electrons, because each line represents a shared pair of electrons. I'm going to subtract that from the total valence number. So I have 3 lines over here, 3 bonds, right? 3 bonds or lines, and it says subtract 2 electrons for each one. So that's going to be 6 electrons. That will leave me with 20 electrons left to put on my drawing. So the next step, it says, is with the electrons remaining, so that's with these 20 electrons that you have remaining there, try to give every outer atom, that's all the atoms that aren't central atoms, so that's going to be this chlorine, and this chlorine. It says with the remaining 20 electrons, try to give each atom an octet, which means make it be surrounded by 8 electrons. So out of those 20, I'm going to give this chlorine here 6 dots. Plus, so this one has 6 lone electrons, plus that line right there represents 2 electrons, right? Plus these 6 lone electrons. So that chlorine right here is surrounded by 6 plus 2, 8 electrons, right? That's what step 3 means. And we've got to do that for each of those chlorines. So this chlorine gets 6 electrons. This one gets 6 electrons. This one gets 6 electrons. And every one of those is surrounded by 8 electrons now when you include the lone pair electrons, which are shown as dots, plus the line that's going to that chlorine, which is another 2 electrons. All right. So in that case, I have given every atom an octet. Then it also says, check these 2 things here. If there aren't enough electrons, then you would have to move a lone pair into a double bond. So if I didn't have enough electrons, I might have to go back here and pick a lone pair here, erase those out. Instead of that being a lone pair, I'd have to move it into a sharing position with that. But that's not going to be the case in this example. All right? So in this example, I'm going to do this step here, though, which says if there are electrons left over, put them around the central atom. Right? So what I just did when I put 6 electrons around each of those 3 chlorines, I used 6 times 3 is 18 electrons, so I still have 2 left over. And they're going to have to go on the central atom. So I'm going to go up here and put 2 dots on phosphorus. Now the phosphorus will be surrounded by 8 electrons also, right? We've got 6 from the bonds, from the lines, plus those 2 lone electrons. So finally, we want to check our work. We want to do that every time. Does your drawing show all the total valence electrons? Yes, it does. We can count them. There's 2 in that bond, 2 in that bond, 2 in that bond. So that's 6 from the bonds. Then I can count up all my dots. There's 2 there, 4, 6, 8, 10, 12, 14, 16, 18, 20. Right? So that's a total of 26, which matches the total valence electrons I had in the beginning. All right. The other thing I have to check is, does every atom except hydrogen have 8 electrons? So, yeah, this chlorine right here has 8 electrons, 6 lone electrons plus the 2 in the bond. All right. This phosphorus gets to count those 6 electrons in the bonds plus the 2 dots, so it has 8. And this chlorine gets to count the 6 dots plus the 2 in the bond, so that's 8. And then finally this chlorine gets to count its 6 dots or 6 lone electrons plus the 2 in the bond. So every atom is surrounded by an octet of electrons.